Is this PPT visible? Okay. See, I think you already know what are the parts basically going to be covered by different teachers. Uh, Other two parts I have already began possibly. The geotechnical engineering one has been divided into three parts that will be covered by respective teachers. So this is the one part that I'm going to cover. So my part will consist of three chapters basically: compaction, consolidation, and subsoil investigation. So these three chapters I'm going to cover. So today, the first class that I'm going to start with, that is compaction of soil. So the basic definition, I'll hope that that has already been covered in your previous classes. As I had a talk with your Orgodip sir, basically Orgodip. So he spoke that he covered some basics, three-phase system, soil three-phase system, and some basic definition you already know, that I'll assume while I'll start this one. So need to know what is unitoid, what is dry unitoid, what is water content, what is degree of saturation. So these definitions, hope you are well known with. Uh, See, compaction, the phenomena basically compaction is associated with to increase the soil strength. If your soil is in a loose state, basically, so what you have to do, cannot properly construct the different engineering structures. So specifically the construction of highway embankment or earthen dams or many other type of projects, you cannot simply just construct on the loose soil. You have to compact it before going ahead with the construction of your particular structure. So this compaction phenomena basically increases the shear strength properties of the soil. So right now it will be difficult for you to understand what is shear strength. That will be covered in due time, basically in this geotechnical engineering one itself. So shear strength, just for now, physically you understand the way the soil can take the load. Basically, there's that amount of increased strength. So whatever the increased strength that is going to come from the construction of a particular structure, your soil should be capable of taking that amount of load. So that is basically quantified in terms of your shear strength parameter, and finally the bearing capacity of the soil. That you will slowly you will study those things. So compaction basically it will increase the shear strength properties of the soil. Then it will increase the bearing capacity ultimately. So that is what basically we will aim at. If you are going to construct a foundation on a loose soil, what you have to do, you have to first compact the loose soil, then you are going to construct the foundation. Then your soil will be capable enough to take the load that is going to come from the construction of the foundation. Now it will also, this compaction will also means stop, or this will also minimize the undesirable settlement that is going to come from the construction of your structure. See, you will learn that, say simply I'm taking a building design. So you are going to construct a particular building. So design of foundation, basically it will, you have to satisfy two criteria. Two criteria is, one is bearing capacity criteria and another one is settlement criteria. So you have to uh, keep your settlement within the permissible limit. So this compaction will also help you to restrict the undesirable settlement caused by the increased amount of stress that is going to come to the soil from the construction of foundation. So basically, overall, what I mean to say here, that because of compaction, basically, you will be able to increase the strength of the soil. You will be increase the bearing capacity, basically. Then you can restrict the undesirable settlement. So those things you will be able to improve within the soil. So that is what basically the reason the compaction is performed. Now here, this slide, let me take the pointer. See, this slide basically shows a comparison between the compaction phenomena and the consolidation phenomena. So consolidation phenomena that will be covered after the completion of the compaction, but at the beginning, if we see the differences, although you will not be completely understand the consolidation phenomena now, but for the sake of now, you can understand physically. Then later on, while the consolidation part will be covered, that time you can understand clearly. So what is the basic difference? So compaction and consolidation, this may appear quite similar phenomena, but these are having distinct. They are having distinct differences between these two phenomena. One is compaction, and another is consolidation. So, what are the differences? First one, if I talk about, that is compaction is basically instantaneous. Whenever you are going to apply the load, your soil will suffer the settlement, and soil will settle, and basically soil will compact then. So it will decrease in volume. But in the on the contrary, consolidation is basically a time dependent phenomena. Time dependent phenomena means it will keep on means happening over a long period of time. So once you apply the load, your distribution or dissipation of pore water pressure will take longer time. So that's why consolidation is basically a time dependent phenomena. Then the second one is soil is unsaturated. This thing you have to be cautious between these two phenomena. In compaction, you have no need to keep the soil saturated. So that's why here we'll assume generally the soil is unsaturated. You are already well known with the term the degree of saturation. Then
Is it desired to be the dry, mostly dry,
what it
or
is desired to be? No. There is a certain amount of water content you need to mix. That will come little later on. But it has not to be fully saturated. Okay, just you understand this thing. But on the contrary, the consolidation, the soil has to be completely saturated. So this is one of the assumption that you will begin with to study the consolidation phenomena, that soil has to be completely saturated. So that is one main difference. Then the last one is densification occurs due to the reduction in air voids. So that is very, very important. In compaction phenomena, you are basically reducing the air voids. You are expelling out the air. But here in this case of consolidation phenomena, basically you are expelling out the water. So as I already mentioned, this consolidation phenomena is time dependent. It is basically, while you apply the load, the soil will experience some excess pore water pressure. Once it experience excess pore water pressure, it will take long time to dissipate out that pore water pressure. Unless the pore water pressure get dissipate out, the soil strength will not increase. So that's why it is said that densification occurs due to the expulsion of water. So as the water start dissipating out, the excess pore water pressure will basically decreases, and the same amount of pressure will transfer to the soil grain, increasing the effective stress of soil. So those term, I think it will be a little bit difficult for you to visualize now. Your excess pore water pressure, then effective stress, but you understand the basic. The densification occurred due to the expulsion of pore water, and in the compaction phenomena, densification occurs due to the reduction in air voids only. And if you see these figures, this three-phase system plot, see this A basically stand for before the compaction phenomena, and this B figure stand for after the compaction phenomena. See here, the soil consists of three-phase system. The soil is here considered the three-phase system. Soil is having solid, water, and air. But here some amount of air is being reduced, so the volume of the soil will reduce. So that, see here, the a little bit the amount of volume of air is reduced. So finally, the soil remain as a three-phase system: solid, water, and air. But if you carefully observe here what is happening in consolidation phenomena, figure A stand for before consolidation, figure B stand for after consolidation. If you see this one, see this is basically a two-phase system. because we have assumed the soil is completely saturated. So it will be only a solid and water, this two-phase system basically consisting of only with solid and water. There will be no air because the soil is completely saturated. And here what is happening, see, the volume of water is being reduced. That's why the settlement is occurring and the soil is getting compacted. So ultimately, there remains the solid and water. So that is the basic difference between this compaction phenomena and consolidation phenomena. Next, if I come to the how we would basically define the compaction. So we can define the compaction. It is basically a phenomena. It is the densification of soil by removal of air, which requires some amount of mechanical energy. What does it mean? See, this is a soil sample, say the grains of soil sample. If you apply some compaction effort or compactive effort, basically some kind of mechanical energy, if you, I can hear some kind of noise. Roktim Mukherjee, you are unmute, I can see. Please mute your microphone. Once you will talk, then only you will unmute. Roktim Mukherjee.
So I think please remove her. Please remove himself.
He is?
Remove himself.
Yeah. Okay. Now it is okay, I think. So what is happening here means some kind of mechanical energy if you apply within the soil. So what will happen? And at the same time, you have to add little bit of water. So if you apply some kind of mechanical energy to a granular soil and not a granular soil as a grains we can assume here, and plus some amount of water if you add, what will happen? The ultimate results you will get the compacted soil. So what is happening here? You have to understand this. So this is the very basic of compaction. See, when you add some amount of water to the soil during compaction, what happened? This water basically acts as a softening agent. There is a lubricants basically around the soil particle. Once it act as a softening agent, what will happen? The soil particle will easily slide over each other and they will adjust themselves into a much compact position. So after you add water and then if you apply some kind of energy within the soil, some mechanical energy, what will happen? The soil particles will easily slip over each other and they will move into a more densely packed position, and the ultimate result is basically the compaction. So water here is acting as a lubricating agent or softening agent, you can say also, that it is helping the soil particle to slide over each other and come into a more denser positions. So finally, the compaction is happening basically. So this is a schematic representations of the compaction phenomena. What basically the basic definition of the compaction we can say, and this compaction is quantified. This is very important. This compaction is quantified in terms of dry unit weight of water. Sorry, dry unit weight of soil. So the ultimate results of the compaction that will quantify in terms of dry unit weight. Now here one thing. So okay, we can move to the next slide. Then it will be better to explain it. Let me take the pointer. See, this is a typical compaction curve. Say we are taking some amount of soil sample, then initially we'll start from adding very minimal amount of water, then slowly we'll increase the amount of water that we are adding to the soil. So once we add water to the soil, what will happen? So obviously you already know that water will help to calm the soil particle into denser position, and the result will be the more compacted soil. Now once the compaction is over, if we take some soil sample and we can measure the basically water content, and then from that water content basically we can find out what is the dry unit weight of soil. Once we are able to measure the dry unit weight of the soil from the first test, say, the next time if we add some increased amount of water, then what will happen, we will get some higher values of dry unit weight. See, this curve basically signify that only if we keep on increasing the amount of water that is adding to the water, that we are adding to the water, what will happen, the dry unit weight, this y-axis is basically who is from where it is coming? মানে এটা মানে কেউ জয়েন করেছে নিশ্চয় তার কাছ থেকেই।
স্যার রক্তিম মুখার্জির থেকে, ওকে রিমুভ করে দিন স্যার।
স্যার রক্তিম মুখার্জি
ও আমাদের ক্লাসে না, ও লেফট করে যাচ্ছে।
বলেও একজন ঢুকেছে, ওকেও রিমুভ করে দিন এক্ষুনি, আপনি অ্যাডমিট করে দিন।
আমি সেকশন এ এন্ড বি, তোমাদের সিআর কে আছে, আমি স্ট্রিক্টলি বলছি তোমরা আইডেন্টিফাই করো এরা কারা, তো otherwise I will not be able to take the class. রক্তিম মুখার্জি, হ্যাঁ সেটা অসুবিধা নয়, কেন কি মানে লিমিট ক্রস করে তুমি থাকতে পারো, অসুবিধা নয়, সেটা মানে ফ্যাক্ট নয়। ঠিক আছে, তুমি বেরিয়ে যাও, গিয়ে ওটাই ঢোকো তাড়াতাড়ি। I cannot find the name Ruktim Mukherjee here.
Sir, he left.
Is he in your WhatsApp group, that Ruktim Mukherjee?
No, sir.
In Geotechnical Engineering 1, whatever the your WhatsApp group is there, is he there? Then how he can get the access of this link?
I think he has changed the name. I think that he has changed the name and joining. He maybe our students, and changing the Google name, he is joining.
Okay. He is from which section he's joining? This section only, I think. Section A.
Sir, he
is
might
it?
be from, he got some hackers are also getting through in the class like this.
Yes, sir, from dark web, yes, sir.
So they get random access to the Google Meets and they join there.
Okay, fine. We can see that. So
ওদেরকে রিমুভও করতে পারবেন না, ওরা আসে আর যখন রিমুভ করার সময় বেরিয়ে যায়। ওদের ওটাই কিছু ওরা জানে যেগুলো আমরা পারি না, ওরা আমাদের ক্লাসের ছেলে নয়।
Yes, sir, from dark web.
এখানে অঙ্কিত প্রসাদ বলে কি একজন লিখেছো, স্যার প্রবাল knows him. প্রবাল, are you here?
Yes, sir. But I don't know him. He's just accusing me. I am actually recording the class also.
Okay, you keep an eye, basically. So try to.
এরা প্রবালের থ্রু দিয়েও পেতে পারে, ও ম্যাক্সিমাম সময় ওই লিঙ্কগুলো অনেক বাইরে শেয়ার করে দেয়।
Yes, sir.
Yes, sir.
Yes, sir. He is just accusing me in every class.
So in every class, this type of thing is happening.
In most of the class, just last 2 and 3 days, it is happening.
So I don't know, means how you are tolerating this kind of thing. You are the students. So if you don't want to join the class, it is okay. We
Hello,
are,
sir.
yeah, I can hear you. Yeah, yeah. Who is saying? So Probal, you try to be cautious. Okay.
Yeah,
So
I don't share the link to the the CRs and the mainly CR sends the link to our official group. So from there, I don't share any link. I know
no,
the
you don't share.
responsibility of the online class.
That is another thing. But that
Sir,
everyone has
he
the
has
access of
access
that
to
link.
dark web.
Yes, sir.
So be cautious. Don't do this type of thing. So don't repeat this thing. Okay. If you have don't have any intention to join the class, you can simply
Yeah,
go
they are
out.
just accusing
I
me.
can I can
I don't because they actually I think they are doing because I am just if you want proof I can give the proof. I am recording the class. If I something I can I if I do something you can see that I am doing because I am the recording the class.
So your friend is accusing you. I am not accusing. So be cautious. So I am saying you this time. Okay, let's back to the class. সেকশন এ সেকশন বি সিআর তোমরা একটু অ্যাটেন্ডেন্স গুলো নেবে বাট শেষের দিকে নেবে আমি বলে দেবো ওকে ওই স্ক্রিনশট নেবে তোমরা so here what I was discussing that the typical compaction curve what is happening here see this x axis basically represent the moisture content and y-axis represent the dry density. As I have already mentioned, the quantification of this compaction ultimately will basically we will do in terms of dry unit weight. So here the y-axis basically represent that dry unit weight and x-axis represent the moisture content. Now here what happens as you increase the water content, see the dry unit weight gradually also increases. And at a certain point it attains the maximum value. See at this point your dry unit weight has attained a maximum value gamma d max. Now if you further increase the water content what happens your gamma d again will start reducing, it will fall down. See, so this maximum value of the dry unit weight this is called the gamma d max and this is called maximum dry density MDD. In short, it is called MDD. And the corresponding water content or corresponding moisture content, it is called the optimum moisture content, OMC. The moisture content at which you will get the maximum dry density, that is called the optimum moisture content. So this is a typical compaction curve. So why this kind of phenomena is happening? If I try to explain it from the lubrication theory, that initially I try to explain the compaction phenomena. What happens here? Once you added lower amount of water, means it will have a certain lubrication effect. But if you keep on increasing the water content, that effect will contribute more. And if this lubrication effect will contribute more, the gamma d max will also increases and it will reach to a maximum value at this point. Now if you add more amount of water that is beyond this point, what will happen? That water, that amount of added water will dilute your soil water system. So the resulting suspension will have a lower gamma d max. So that's why what is happening beyond this point, this gamma d is falling down after reaching a maximum value. So this is a simple explanation basically for this kind of behavior or this kind of compaction curve. Later on we'll try to see the more rational explanation from the your what to say soil structure perspective. We'll see that is called the Lamb-based theory that we'll see little later. So this was a typical compaction curve. Now See, standard Proctor test. Here in basically compaction that is that gamma D max and OMC, that is MDD and OMC, maximum dry density and optimum moisture content, that is basically measured in the laboratory by using standard Proctor test. The test is called the standard Proctor test basically. So it is having an IS version, that is Indian standard version, that is light compaction test, that we'll see little later on. Just now we'll see the standard Proctor test. Let me read little bit here what it is written. In the standard Proctor test, the soil is compacted in a mold that has a volume of 944 centimeter cube. See, this is the mold. Basically, this is mold. There is a detachable collar is there. Some of this kind of collar here. This is called the extension. The diameter of the mold is 101.6 mm. So the diameter of this mold is 101.6 mm. The soil is mixed with varying amount of water and then compacted in 3 equal layers by a hammer that is given in this figure. The hammer weight is 2.5 kg and the drop height of the hammer is 30.5 mm. So this is a hammer. Basically, it is having a drop height of 30.5 kg and a mass of 30.5 mm and a mass of 2.5 kg. See, say we are first considering the first amount of water content, first assigned water content. Basically, say initially little amount of water we have added. Then what you have to do, we have to mix the soil thoroughly with the water. Now what we have to do, we have to fill this mold into 3 different layers. First layer you fill, then you compact that layer using this hammer, using this hammer with 25 number of blows. Once the 25 number of blows is completed, then you add the next layer, and similarly you apply another 25 number of blows and you compact the second layer. Then you add the third layer, then again you apply the 25 number of blows. In this way you finish the compacting the soil with 3 number of layers using 25 number of blows. So once it is done, what you have to do, you have to take the weight of the entire mold, whatever the mold, and initially you have to take the weight of the empty mold. If you take the weight of the empty mold, and also if you take the weight of the entire assembly after filling up it with the soil sample, what happened? If you subtract these two, that is weight soil plus mold minus the weight of mold, you will get what is the weight of the wet soil that you have compacted within that mold. So from that, we can basically find out the unit weight of compaction. Moist unit weight of compaction we will basically define. So moist unit weight of compaction, how we can find out? That the gamma will be equals to W by Vm. W is the weight of the compacted soil in the mold, and Vm is the volume of the mold. That is a standard volume, 944 centimeter cube. So this way you can get the moist unit weight. Now what you have to do, once that taking the weight is over, you collect little amount of soil sample from the mold and then you put it into the oven. Once you put it into the oven, you have to take out that soil sample from the oven after 24 hours. After the soil sample got fully dried, then you can easily calculate what is the moisture content the soil had. How you get the moisture content? Moisture content is having a simple formula, weight of water by weight of solid. So how you will get the weight of water? If you know the moist weight minus the dry weight after taking out from the oven, if you take the weight of that soil, you will get the dry weight. So subtracting these two, you will get the weight of the water, then weight of the solid that after taking out from that oven, whatever the weight you take, that is the weight of the solid. So if you take the ratio of these two, that is weight of water and weight of solid, what you will get? You will get the water content. So we need to know these two quantities. One is moist unit weight of the compaction and another one is unit water content. Once we know these two quantities, then we can find out the our desired quantity of dry unit weight, that is the gamma D. So gamma D is having the formula we already know. You hope you are familiar with this formula. Gamma D is equals to gamma by 1 plus W. Gamma, this is the moist unit weight of compaction, and W is the water content. So you know how to determine these two. So you can easily get the gamma D for that particular from that particular test. Now, once you get the gamma D and the corresponding water content from one test, now you have to repeat the test. Now you have to repeat the test for several other water content. So initially you had added little amount of water while you prepare the soil sample. Now what you have to do, you have to increase the amount of water that you will mix with the soil sample. So once you add the little bit increased amount of water content and you mix it with the soil sample, and again if you compact the soil sample using 3 different layers with 25 number of blows each time, then if you repeat this calculation, you will get another one set of gamma D and water content. So in this way, if you repeat the test 3 or 4 times, then what you will be able to do, you will be able to form this kind of graph, this kind of compaction graph. So this is basically called the compaction curve. Here that I have already explained, y-axis contains dry unit weight and x-axis contains the moisture content. So you have several sets of data, that is dry unit weight and corresponding moisture content. So if you plot it here, then you can easily get this kind of variation. See, you might not get this kind of simple smooth curve. Rather, you can get your point, say something like this. This is one point, say this is another point, this is say another point, some point maybe on the graph. So in this way, you will get the points of gamma D and corresponding water content. Then you have to, what you have to do, you have to approximate a graph out of this data basically. So this kind of graph, once you form, you can easily find out what is the maximum value of the gamma D. That is basically your MDD, that is maximum dry density. And the corresponding water content is basically the OMC, that is optimum moisture content. So this is the standard Proctor test, and the results you get from the standard Proctor test, you have to okay, ignore it. What we can do means so once we accept, nothing can disturb us, is it? Okay, fine. Move on. So this is the typical results from the standard compaction test that we have to basically find out. Means you have to conduct this test in the laboratory itself. In this semester, probably you don't have any soil laboratory. I cannot remember. So if you have the soil laboratory, so in the first soil laboratory, probably compaction test is not there. In the second soil laboratory, you are going to do it. So you will have to do the test, and you have to form this kind of compaction curve, and from this compaction curve, we have to find out the OMC and MDD. Now here, if you closely observe this curve, see here, you can see there is another graph. It is like this. So this is called the zero air void curve. Now, means we have to form this zero air void curve also. So let's see how to form this curve. So far we have understood how to form this compaction curve, but we don't know yet how to form or how to generate this zero air void line. Say, what is zero air void line basically? So the definition, if I try to define it, it will be basically at a particular water content, we might have reached the maximum value of the dry unit weight corresponding to this zero air void line. So it is not possible actually. This is a purely theoretical concept to attain the zero air void line, because you, whatever the amount of compaction energy you use, you give it to the soil, you will never be able to completely remove the air, complete air from the soil. So that's why this line is basically a theoretical concept. But theoretically we can get the maximum gamma d like this, but we get the value here only. So that maximum value, basically at zero air void, that is the when degree of saturation is 1. So that theoretical curve is basically called the zero air void line curve. Now let's see is how to find out that zero air void density for different water content. So for a given moisture content W and degree of saturation S, the dry unit weight of compaction can be calculated as follows. See, this is a standard formula you already know. Gamma D is equals to Gs into gamma D, gamma W by 1 plus E. Gs is the specific gravity of the soil solid, gamma W is unit weight of water, and E is the void ratio. Now, if I replace this E from this simple relation, that is AC equals to Gs into gamma W, specifically we are going to replace E using the degree of saturation. So E, we are going to replace it, and here we have replaced it. And finally, if I come simplify it a little bit, the final form of zero air void density, it will come like this expression. How I got it? Here, the degree of saturation, I have kept it 1. That is 100% degree of saturation. Because at zero air void, the void will be filled with water. From the definition of that degree of saturation, we know that. What is the definition of the degree of saturation? Volume of water by volume of void. So if your volume of void is completely filled with water, then there will be no air void left. So that is when your degree of saturation is basically 1. So that's why we have put the degree of saturation value 1 to get this final expression of zero air void density. So gamma ZAV equals to gamma W by W in plus 1 by G. So this is the final expression. Now we have to know the specific gravity of the soil solid, that is having a standard value nearly 2.6 to 2.5 to 2.665 like that. So GS, we can assume a value of GS, or we can exactly determine that value. And gamma W, we already know what is gamma W. And for different values of moisture content, if I vary the moisture content only, then we will get the zero air void density. This GS is known, this gamma W is known. Just if we vary the moisture content, then we will get zero air void density for a particular moisture content. So if I repeat this calculation for different values of moisture content, then I will get a set of values of zero air void density along with the water content. Once we get the several set of this data, we will be able to plot it, and that is how we will get the zero air void density. So be cautious, try to practice the problem based on this to calculate the compaction curve as well as zero air void density curve. So I may ask you to plot the compaction curve and find out the OMC and MDD, and also plot the zero air void curve. So you have to be very, very clear about the concept, how to form this kind of compaction curve, how to form this kind of zero air void line. You have to be very, very clear about this. I think somebody was waiting, knocking.
Yes, sir, don't join, sir. Don't join him, sir. He is not from our class.
Sir, he is not from our class.
Okay. Try to identify this kind of insects. See, as I already mentioned, that there is a name of that IS standard, that Indian standard for the standard Proctor test. So here are the Indian standard for the Proctor compaction test. There are basically two variant of the test are there. One is the light compaction test, and another is the heavy compaction test. Now, So the standard Proctor test that we have just understood the main concept of that, how to get that compaction curve using standard Proctor test. That standard Proctor test is known as light compaction test as per IS specification, IS 2720 part 7 1974. And here just a very simple modification has been made. What is that? The volume of the mold is 1000 cc. Earlier we saw for the case of standard Proctor test, it was 933 as far as I can remember. And here they have modified it, keeping the value 1000 cc. And the weight of the hammer is 2.6 kg and drop is 310 mm. These also a little bit modified. So this is basically the light compaction test, and there is another variant of standard Proctor test that is called the modified Proctor test, and that modified Proctor test is known as heavy compaction test. That is specified in IS 2720 Part 8 1983. So you have to collect this IS code also, or from any textbook you can read this light compaction test and heavy compaction test. And here see, in the case of modified Proctor test or heavy compaction, yeah. Oh, you have a class now?
Yes, sir. Geology laboratory.
Oh, it is already 3:30. Fine, then from next class we'll continue this I think factor affecting compaction. Then modified Proctor test little bit, then I'll enter into the field compaction. Okay, I think I could not cover much thing because it was
The next class will be offline.
possibly next class will be offline. So I requested your CR to give me another online class, because in the previous week there was holiday possibly as far as I can remember. So if you can give me 1 or 2 class online, I can cover something. Otherwise it will be difficult. So obviously from the next week onward, there will be offline classes as per the instruction from the university. Okay. Yeah, means we have just got that GO, means government order from that West Bengal government, but means specific instruction yet to come from the university. So that will come very soon, possibly. If you have any doubt, you can ask me very briefly. I can answer. And meanwhile, section A and B CR, you can collect the attendance. Once you take the attendance, please send me into my WhatsApp. Okay. So if you don't have any doubt or any questions, you can leave for your next class. I think you are getting delayed.
Okay, sir. Thank you.
Just confirm that the attendance has already been taken.
Sir, will you share the PPT?
At the end of the class, I'll share. After I cover this compaction chapter, I'll share that one.
Thank you, sir.
Okay.